All right. We are going to be doing our second and final review for our final for Secondary Math 2. Okay, so let's just go ahead and jump right into it. Okay, so for the whole first page, numbers 1 through 8, we are going to be using trigonometry. Okay, so it's asking us to find the value of each trigonometric ratio. Okay, well, let's remind ourselves what these trigonometric ratios are. Okay, we learned that there are 3 trigonometric ratios that we talked about this year. We have sine, which equals opposite over hypotenuse. We have cosine, which equals adjacent over hypotenuse. And then we have tangent, which equals opposite over adjacent. Okay, we can think of that as so, ka, toa. All right, so if we look at number 1, it's asking us to find the cosine of x. Okay, so it wants cosine of angle x. So first of all, we need to identify what angle we're standing at. Okay, we are standing at angle x right there. Okay, then based on where we're standing, we now can label our sides either opposite, adjacent, or hypotenuse. Okay, well, the hypotenuse, that one's pretty easy. That's always across from our right angle. So that one's going to be 25. Okay, our adjacent is the side that is next to our angle or almost like attached. So that is our adjacent. And then opposite, if we were walk to the opposite side, it would be 7. Okay, so now all we have to do, we have all of our sides. We want cosine of x, so we say the cosine of x is equal to, back over here, adjacent over hypotenuse. So our adjacent, 24, over our hypotenuse, 25. And there we go. Okay, so let's do the same thing for number 2. Okay, so now it's asking us for tangent of angle A. So again, first identify what angle you're standing at. We're standing at angle A. Okay, so then based on where we're standing, we can label our 3 sides. 50 is our hypotenuse across from our right angle. 30 is the side that's next to our angle, so that's going to be our adjacent. And then 40 is, if I were to walk to the opposite side, opposite. Okay, so now we have our sides labeled. We just need to identify which 2 we need to use for tangent. Well, that's going to be TOA, so opposite over adjacent. So we have the tangent of A is equal to opposite, 40, over adjacent, 30. Okay, now, if you were to enter this into your computer, yes, this is technically right, but it might mark it wrong because it's not reduced. Okay, so we can reduce 40 over 30. We can divide each of these guys by 10, which would give us 40 divided by 10, 4, 30 divided by 10, 3. So our final answer is actually 4 over 3, the reduced fraction. Beautiful. All right, let's do that again. Number 3. It's now asking for tangent of angle Z. Okay, so we are standing at angle Z this time. Based on where we're standing, we can label all 3 sides. 20 is our hypotenuse, probably the easiest one to identify. He's across from our right angle. 12 is the side that's next to angle Z, so that's our adjacent side. And 16 is on the opposite side of our angle Z, so opposite. All right, so now we have the tangent of angle Z is equal to, again, tangent goes with TOA, opposite over adjacent. So we have opposite, 16, over adjacent, 12. Now again, this fraction is technically right, but it is not reduced. We can divide 16 and 12 both by 2. Yes, they're even, but we can skip a step and divide them both by 4. Okay, so if I were to divide these guys both by 4, to reduce it, divide by 4, I'd get tangent of angle Z is equal to 16 divided by 4 is 4, and 12 divided by 4 is 3. 3. So again, that would be the correct simplified reduced answer. Awesome, let's do that one more time. So now we have sine of angle x. So we're standing at angle x. Okay, so based on this angle, we can label our sides. So we have 50, again, is our hypotenuse. 40 is going to be our adjacent side this time. And then 30 is our opposite side. Okay, so now that we have those labeled, we can say that sine of angle x is equal to, well, let's look up here. Sine always goes with opposite over hypotenuse. So we have opposite 30 over the hypotenuse 50. Okay, now again, this can be reduced. They both end in a 0, which means we can divide them both by 10. Divide by 10, divide by 10, which would give us sine x is equal to 3 over 5. And there we go. Perfect. Okay, so now for numbers 5 through 8, it's asking us to find the missing side, round to the nearest tenth, which means we'll probably have a decimal. Okay, well, we know that there are a couple ways to find missing sides of right triangles. Okay, we can use the Pythagorean Theorem when we have 2 of the 3 sides. Okay, well, we don't have 2 of the three sides. We have one side, missing side, and an angle. So this is where we have to use, again, so, ka, or toa, trigonometry. Okay, so, ka, or toa. Okay, so the first thing we have to do is identify what angle we're standing at. Well, that's pretty easy. It's just the angle that it gives us. So we're standing right there at 67. Now, based on where we're standing, what 2 angles does it give me? Okay, even though I don't know one of them, which 2 angles is it giving me? Or not angles, excuse me, sides. Which 2 sides is it giving me? Okay, well, this one's across from my right angle, so that's our hypotenuse. And this one is right next to our 67, so that's our adjacent. Okay, well now we need to identify which function we need to use, sine, cosine, or tangent. And that's based on which 2 sides we were given. Okay, well I was given adjacent, which shows up in cosine and tangent. And I was given hypotenuse, which shows up in cosine and sine. Well, the only function that has 2 check marks is cosine. So we know we have to use cosine. Okay, so I'm going to set this up. Cosine of the angle, this time it's 67, equals adjacent x over hypotenuse. Okay, and now we just need to solve for x, which means we need to look at our side with our x. Okay, well, the only thing I need to get rid of is the opposite of divide by 18, which is going to be to multiply by 18. So now I have x is equal to 18 times the cosine of 67, which that I'm just going to punch in my calculator, which in fact you need a calculator. Okay, so now I'm going to do 18 times, here's my little cosine button right there, cosine of 67. And I get 7.03. It wants it rounded to the nearest tenth, which is the first spot. So we look behind this 0. Since the 3 is below 5, we're not going to round up. So our final answer is x is equal to 7.0. And there we go. Okay, let's do that again. Okay, so for number 6, identify the angle where we're standing. Okay, so I'm standing here at this angle at 29 degrees. Which 2 sides am I given? Okay, well, I'm giving the opposite side and my adjacent side. I'm not given the hypotenuse. We don't care about the hypotenuse. Okay, so again, now we need to decide what function we're using based on the two sides we're given. Okay, well, I was given opposite, which shows up in sine and tangent, and I was given adjacent, which shows up in cosine and tangent. Okay, well, the function with two check marks, tangent. So we know we're going to have to use tangent, so we set it up. Tangent of the angle, 29, equals opposite over adjacent. Opposite, 12, over adjacent x. Okay, so now we need to solve for x. So look at our side with our x. Now, you might think, oh, well, I can just times by 12. But this is not saying divided by 12. This is saying 12 divided by x. Okay, remember that rule where we cannot solve for x when x is on bottom? We actually need to move the x first. So the opposite of divide by x is going to be to multiply by x on both sides. So now I have x times tangent of 29 equals 12. Okay, well now my x still isn't by itself, so look at our side with our x. This is saying times by tangent of 29. Well, what's the opposite of times by tangent of 29? We're going to divide by tangent of 29 on both sides. Okay, and this now is what I put in my calculator. So now I have 12 divided by tangent of 29. And I get 21.64. We want it rounded to this spot, so look behind it. The 4 is less than 5, so our 6 stays a 6. So final answer, 21.6. And there we go. All right, let's do that again. Number 7. Okay, we're standing at angle 17 degrees. Based on that, the two sides that I have now are my adjacent side. That 10 is right next to it. And the x is across from my right angle, so hypotenuse. Okay, so now we need to decide, are we going to use sine, cosine, or tangent? Okay, well, I'm given adjacent, which shows up in cosine and tangent, and hypotenuse, which shows up in sine and cosine. Okay, well, the one with two check marks, cosine. So now I can set this guy up. Cosine of the angle, 17, equals adjacent over hypotenuse, so 10 over x. Okay, so now we need to solve for x, but again, x is on bottom, so we need to move him first. So do the opposite of divide by x, which is times by x. Okay, so now I have x times cosine of 17 equals 10. Now we need to look at our other side with our x, because it's not by itself yet. So the opposite of times by cosine of 17 is divide by cosine of 17. This is what we're going to punch into our calculator to get our x. Okay, so let's go ahead and pull out our calculator. So now I have 10 divided by cosine of 17. 10.45, we want it to the nearest tenth, so we look behind the 4. Because it's a 5, it's going to bump that 4 up. So our final answer, 10.5. Beautiful. Okay. Last one for our trigonometry. We are standing at angle 74. Based on where we're standing, I'm given the opposite side. That x is on the opposite of my 74. And then 12 is across from my right angle, so hypotenuse. Okay, so based on this, are we going to use sine, cosine, or tangent? Okay, well, it gave me the opposite, which shows up in sine and tangent. And it gave me the hypotenuse, which shows up in sine and cosine. Two check marks, we are using sine. Okay, so we set this guy up. Sine of the angle, 74, equals opposite, x, over hypotenuse, 12. Okay, we're solving for x, so look at our side with our x. Our x isn't on bottom this time, so we can go ahead and just do the opposite of whatever. Let's divide by 12, so we do the opposite, which is multiply by 12. Okay, so now in my calculator, I'm going to type in 12 times sine of 74 to give me my x. So let's go ahead and do that. I got 12 times sine of 74. 11.53, I want it to this space, so look behind. The 3 is below 5, so this is going to stay 11.5. And there we go. Okay, let's go to our next page. Alrighty, so the next big thing we talked about are transversals, transversal relationships. Okay, so we talked about a few different types of relationships. Okay, so let's go ahead and identify, because the first thing we have to do is asking us find the measure of the angle indicated in bold. Okay, and we have some x's. We actually don't even know what either of these angles are. Okay, but we can identify the relationship and then solve for x using that relationship and then plug x in. Okay, so these two angles that I'm given, x plus 126 and x plus 78. These guys are on the same side of my transversal, and they're both on the inside of my parallel lines, which tells me consecutive interior. Okay, well, consecutive interior angles, if you remember, are always equal to 180 degrees, which means they add to give me 180. Okay, so that's how we're going to solve for x. We're going to take one of them, x plus 126, add it to the other one, x plus 78, and they both equal 180. Okay, well now I can solve for x. So looking at my side with my x's, I see some like terms I can combine. First of all, I can combine my x's. 1x plus another x is going to give me 2x. Then I can combine my constants, 126 plus 78. 126 plus 78 is going to give me positive 204. And it still all equals 180. We haven't moved anything, so we haven't affected the 180 yet. Okay, so now I can start solving for x. Okay, well, the first thing I got to get rid of is the 204 because it's farthest from my x. So I'm going to subtract 204. So I get 2x is equal to 180 minus 204 is negative 24. Okay, my last step, opposite of times by 2, is divide by 2. So I get x is equal to negative 12. Okay, now that's not our final answer. It wants us to find the measure of the angle indicated in bold, and if you can't tell, it's this angle right there. Okay, so we're going to take that negative 12, plug it in where our x goes. So now I have negative 12 plus 78, because it was x plus 78. Okay, well that's pretty easy. Negative 12 plus 78 gives me a positive 66 degrees. And that is our final answer. So we know that angle right there in bold is 66 degrees. Okay, let's do that again. First things first, we need to identify the relationship. Okay, so I see that they're across from each other on this like X-looking thing. So that tells me these guys are vertical angles. Okay, and if we remember, vertical angles equal each other. Okay, so how we set this equation up is we take the top one, which is our one in bold, and set it equal to the other one. So I have 15x plus 10 equals 17x minus 6. Okay, well, in order to solve for x, I need all my x's on one side. So I'm going to move the 15 because that's smaller, so I'm going to do the opposite. Subtract 15x, subtract 15x, 10 is left over here. 17x minus 15x is 2x, and the minus 6. Okay. So now I can solve for x. The first thing I have to get rid of is negative 6. I do the opposite, which is to add 6 to both sides. 16 equals 2x, or 2 times something is going to give me 16. Okay, last step, divide by 2. Divide by 2. X is equal to 8. Now again, that is not my final answer. I need to take that 8 and plug it in to where our x is in bold. So that's right there. So now my answer is going to be 15 times x, which we know is 8, plus 10. Okay, well, 15 times 8 is, let's see, 120. 120 plus 10 is 130. So that is our final answer. We know that that angle is 130, which technically means the other one angle is 130 as well. Alrighty, number 3. Okay, so this relationship, probably one of the hardest to, at least for me to remember. Okay, so I see that they're on the same side, but one's on the outside of my parallel lines, one's on the inside. And we notice they're both in like the top right corner of these little four squares. So when they're in the same spot, these are called corresponding. Okay, and we know that corresponding angles equal, again, each other. Okay, so that means we can take one of them, 37x minus 1, and set it equal to the other one, which is our one in bold, 5 plus 35x. Okay, well, in order to solve for x, again, I need all my x's on one side. I have 37 over here, 35 over here, so I'm going to move the 35 by doing the opposite. Subtract 35x. So now I have 37 minus 35 is going to give me 2x minus 1 that was over there equals 5 left on that side. Okay, easy peasy. Now I can solve for x. So looking at my side with my x, I got to get rid of negative 1 first. Do the opposite. Add 1. 2x equals 5 plus 1, which is 6. Last step, opposite of times by 2 is divide by 2. So our x is equal to 3. Again, not our final answer. We need to take that 3, plug it into the x where it's bolded, which is right there. So now I have 5 plus 35 times 3, because that's where our x was. Now, we need to multiply before we can add, right? We got to follow PEMDAS. So let's take 35 times 3, which gives me 105. Well, 5 plus 105 is going to give me 110 degrees. And that is our final answer. Beautiful. Alrighty, another relationship. Okay, so this one, I see that they're on, one's on the left side, one's on the right. So that tells me alternate. And they're both on the outside of my parallel lines. So this relationship, alternate, exterior. Okay, well, we remember that alternate, exterior, or interior equal each other. Okay, so again, that means we can take one of them, our top one in bold, 15x plus 5, set it equal to our other one, 16x plus 2. Need to move all my x's to one side, so I'm going to move the smaller one, subtract 15x, subtract 15x. 5 equals 16 minus 15 is just 1x plus 2. Okay, well now there's just one thing I got to get rid of to get x by itself. It's the opposite of plus 2, which is minus 2. So we get x is equal to 3. Again, not our final answer. Let's take 3 and plug it in to where we see the X in bold, which is right there. So now we have 15 times 3 plus 5. Okay, well again, we need to multiply before we can add. So 15 times 3 is going to give me 45. 45 plus 5 is 50. So final answer, 50 degrees. Beautiful. Alrighty. Okay, number 5, relationship. I see that they're on different sides of my transversal again, and they're both on the inside of my parallel line. So these guys are alternate interior. Again, alternate exterior or interior equal each other. Okay, so let's go ahead and take the one below in bold. 7x plus 17 equal to that one, 8x plus 8. Okay, move all your x's to one side. I like moving the smaller one, so we're going to subtract 7x. Subtract 7x. 17 equals 8 minus 7. It's just 1. And plus 8. Okay, only one thing I got to do to get x by itself. Opposite of plus 8. Subtract 8. So I get x is equal to 9. Okay, well now we need to take that 9, plug it into where our x is in bold, right there. So now I have 7 times 9 plus 17. Okay, let's multiply before we add. 7 times 9 is going to give me 63. 63 plus 17 is 80 degrees. And there we go. Okay, last one for our transversals. So now, this relationship, I see a couple things. I see that they're right next to each other, and when they're right next to each other, they make up this straight line. Okay, a few different words or names that these are called. We can call them adjacent, linear, or supplementary. Okay, well, these guys all mean they add to 180. They do not equal each other. They add together to give me 180. Okay, so that's how we have to set this equation up. We got to take one of them, negative 2 plus 13x, plus the other one, 33x minus 2, and it all equals 180. Okay, well now on my side with my x's, I don't have to move any of the x's. They're all on one side, but I need to combine like terms. Okay, so now I have 13 plus 33, which is going to give me 46x. And then I have negative 2 minus 2 more, so negative 4, all still equals 180. Okay. So now we can just start getting rid of stuff. To get x by itself, I have to get rid of negative 4 first. It's farthest from my x. So we're going to add 4, add 4. 46x left on this side equals 184. And my last step for getting x by itself, opposite of times by 46, is divide by 46. So 184 divided by 46 gives me 4. Again, not our final answer. Let's take that 4, plug it into our x in bold, which is right there. So now I have 33 times 4 minus 2. Okay, let's multiply before we subtract. 33 times 4 gives me 132. Minus 2 is 130 degrees. And there's our final answer. Beautiful. All right, next page. Final page, don't worry. Okay, so the last thing we talked about are what we call complex numbers. And we get these like square roots, we get i's in them. Okay, so first thing I want to remind ourselves are simplifying these radicals. Okay, so whenever we're simplifying a radical and it's taken to the square root, we need to find a pair of numbers that can come out. Okay, well, let's just focus on the number first of all. Let's just take 288 and start dividing it. Okay, well, I'm just going to try 288 divided by 4, and I got 72. Okay, 4 can be divided to 2 and 2, which gives me a pair, but I'm going to hold off for a second. 72, I can divide by 8 times 9. Again, 9 gives me a pair of 3 and 3. I'm going to hold off before taking them out, because I'm going to see if 8 can break down. I get 4 and 2, again, 2 times 2. Alrighty. Okay, so I went kind of fast, but I'm just breaking down these numbers to see where I can get pairs that'll come out. Well, I had a pair of 2s, another pair of 2s, and a pair of 3s, and 1 2 that had to stay inside. So, inside our radical, we had a 2 that had to stay in. Outside, we had one couple of 2s, another couple of 2s, and a couple of 3s. Okay, whenever they're going out or staying in, remember they're all being multiplied together. Okay, so we took care of the number 288. Now we need to take care of the x's. Well, I have x to the 4th, which means I have 4 x's being multiplied together. So now I can, from that, say, oh, there's a pair, and there's a pair, and nobody had to stay inside because it's not an odd number. So since I had 2 couple of 2s, that becomes x squared. Okay, so my final answer, I'm just going to multiply these all together. 2 times 2 times 3 is going to give me 12. X squared, because I got 2 couples of x's, and then root 2 that had to stay inside. And there we go. Okay, let's do the same thing for number 2. Let's just start breaking 294 down. Okay, so 294, I'm going to try and divide it by kind of a bigger number. Let's try 8. Why not? Nope, that didn't work. 294 divided by 4. Nope, didn't work. Let's try 294 divided by 2. I know it's even, so it can be divided by 2. I get 2 times 147, kind of a weird number. Let's try dividing 147, maybe by 3. Oh, okay, that worked. 3 times 49. Okay, notice I don't have any pairs yet. I have a 2, a 3, and a 49. Okay, so now I can take 49. I like that number because it gives me a pair of 7s. Okay, so from that, I see the only pair that can come out is my 7, 1 couple of 7s. The 2 and the 3 actually had to stay inside, so 2 and the 3 had to stay inside. Okay, well, we took care of the numbers. Now let's take care of the variables. So I have x cubed, which means x times x times x. Okay, well, in 3 x's, I can pair up 2 of them to create 1 couple, but then 1 x had to stay inside. Okay, so let's go ahead and simplify this guy. So 7x got to come out. 2 times 3 turns into 6 with the 1x left inside. And there we go. All right, so now we're moving into what we call complex numbers, where we have a regular number plus or minus a number with an imaginary number attached to it, right? Whenever we have a number with an I, that means it's an imaginary number. Okay, so what we want to do is whenever we have an addition sign in the middle, it's just like we're combining like terms. Okay, remember when it's addition, basically it means we're multiplying by those signs, but the signs don't change. Okay, so we can just copy down the first one always when we're adding and subtracting. -6 plus 6i. Okay, well, this was a -5. It stays a -5. was a positive 7, 7i, stays a positive 7i. Now I can just combine like terms. Okay, so I have my constants, which usually go in front. So I have negative 6 minus 5 more. It's going to give me negative 11. And then I have 6i plus 7i is going to give me positive 6 plus 7. I'm double checking. Yep, 13i. And there we go. Okay, now for number 4, I actually want to change it a little bit. So we did an example where it was addition. Now I want to change it where we are subtracting. Okay, so now that I changed it to subtraction, what this does is it changes the signs after it. Okay, we know that rule. Okay, so remember that we can always copy down the first one, negative 6 plus I. Well, now, since it's subtracting, it changes. So this was a negative 4. Now it's positive 4. This was positive 7i. Now it's negative 7i. Okay, and now we can just combine like terms. So again, let's do our constants first. Negative 6 plus 4 is going to give me negative 2. And then 1i minus 7i. So 1 minus 7, negative 6i. And there we go. Okay, now on numbers 5 through 8, we're not adding and subtracting anymore. We are multiplying, which means we need to write down a very important rule when multiplying. Okay, remember that I squared, whenever you see an I squared, it turns into negative 1. Okay, so that rule is going to be important. So let's go ahead and look at 5. So it kind of looks like multiplying two binomials, right? Instead of an x, it's just an I. So what I'm going to do is I'm just going to use our FOIL method. So I'm going to take f, my first, times my first, 2 times 6, 12. O, outside, times my outside, 2 times 3i, is positive 6i. Inside, 2i times 6 plus 12i, and then out, or last times my last, 2i times 3i is positive 6i squared. Okay, so remember our important rule. This I squared turns into negative 1. So this is actually 6 times negative 1 at the end. Okay, so this turns into 12 plus 6i plus 12i. 6 times negative 1 is minus 6. Notice we don't have any I squareds left. So now we can just combine like terms. Again, let's do our constants first. 12 minus 6 is 6. 6i plus 12i gives me 18i. So you should never see an I squared in your answer because that made it turn into a negative 1. Okay, number 6. This guy looks a little weird because we have these two just like negative 2i times 3i. I'm actually going to multiply them first. Okay, I'm going to ignore this last guy for now. So negative 2i times 3i turns into negative 6i squared. Wait. What does I squared always turn into? So this turns into negative 6 times negative 1. Okay, well, negative 6 times negative 1 is positive 6. Now I'm just going to bring down the other one I haven't used yet. So 6 times 3 plus 6i. Okay, well, now it becomes pretty easy. It just becomes our distributive property. 6 times 3, 6 times 6i. 6 times 3, 18. 6 times 6i, 36i. And there we go. Okay, last two examples. Okay, so again, this one is like multiplying our binomials. So I'm going to do the FOIL method. So 5 times negative 6, my first terms, or negative 5 times 6 is negative 30. Outside, negative 5 times negative 5i, negative times a negative, positive 25i. Inside, negative 4i times 6, negative 24i. And then my last, negative 4i times negative 5i, positive 20i squared. Okay, well now our rule, I squared turns into negative 1. So this turns into 20 times negative 1, okay, which turns into negative 20 at the end. Okay, then I'm just going to copy down the rest. Negative 30 plus 25i minus 24i and minus 20. Okay, let's go ahead and combine our like terms. Do our constants first. Negative 30 minus 20. Okay, that's going to give me negative 50. 25i minus 24i. 25 minus 24 is just positive 1i. Beautiful. Okay, number 8. This guy is written a little differently. Okay, this is saying negative 4 minus 3i squared, which actually means, looks like this, negative 4 minus 3i times itself, negative 4 minus 3i. Okay, so now that I've split it into two binomials, I can just multiply like I've been doing. So take my first terms, negative 4 times negative 4, positive 16. My outside terms, negative 4 times negative 3i, positive 12i. Inside terms, negative 3i times negative 4, positive 12i again. And my last, negative 3i times negative 3i, positive 9i squared. Okay, well, I squared, we always turn into negative 1, which means this is 9 times negative 1 at the end, which turns into negative 9. Copy down the rest, 16 plus 12i plus 12i. And we can combine like terms. Do my constant, 16 minus 9 gives me 16 minus 9 is going to give me 7. Then I have 12i plus 12i, so 12 plus 12, positive 24i. And there we go. Okay, those are your notes. There's an assignment that goes with it.